So now that we've talked about Java lambda expressions and Java method references, let's turn our attention to a very important interface family called functional interfaces, which are provided in support of lambda expressions and method references. And so I'll talk about that concept first, and then we'll kind of talk about some of the functional interfaces we're going to cover in more detail throughout the rest of this material. These features, functional interfaces, lambda expressions, method references, and so on, form the basis for Java streams and Java's concurrency and parallelism frameworks. Even things like Java reactive programming, which is well beyond the scope of this class, but something else that's quite fascinating. So understanding functional interfaces is very important to make sense of other advances that have come to Java over the past decade. Okay, so let's talk about what a functional interface is. A functional interface is an interface that contains one and only one abstract method. So a good example would be the runnable interface, which has one run method, or the callable interface, which has one call method. There's only one method. There can be only one, much like the movie The Highlander. A functional interface is also the type used for a parameter when a lambda expression or a method reference is passed to a Java method. Let's take a look at an example. This is an example that we're going to look at in another context later. This is the run test method. And it's a helpful, reusable method. And what it does is it's going to record the start time, apply a function, and then record how long things took to run, and then it'll do something with that. It'll stash it away somewhere so we can find out how long it took to run later. And in this particular case, we're using it to record and print the time taken to compute the nth factorial. So in this particular case, you can see we're passing in a function parameter. So there's a functional interface in Java called function, which takes two types, a parameter type and a return type. And this will be used to parameterize the factorial implementation. So you can see inside the run test method, we say fact.apply, and we pass in the value of n, which is the thing we're computing the nth factorial for. And then down here, you can see how we can call the run test method with different factorial implementations. We can have a parallel stream factorial. We can have a sequential stream factorial. And this is an example of behavior parameterization. We can parameterize the function that we're passing to the run test method. But we're passing it really as an object that happens to have a single method called apply. That's the functional interface single abstract method. Just for kicks, here's an implementation of the parallel stream factorial method that goes beyond the scope of this course in a way, but I just want to show it because it's kind of fun. So we take a big integer n, we take that n and we create a stream of long values from 1 to n. Then in parallel, we're going to process all these things in parallel. In parallel, we're going to convert each of the longs to a big integer, which is an arbitrary precision integer. And then we're going to apply something called a reduction terminal operation, which is going to multiply these various values in that range from 1 to n in parallel and reduce it to a single result, which of course will be the nth factorial, which could be very gigantic, as it turns out. So just a fun example just to illustrate how you can use these things in the context of modern Java functional programming. There's a lot of functional interfaces that come predefined out of the box. There are dozens of them. And you can see some of them here, things like function. We have other things like by function. We have consumer, there's supplier, there's predicates, and so on and so forth. Some of these interfaces handle so-called reference types, which are Java types that are going to have essentially indirection involved with them. Others support primitive types. So there's a bunch of types for things like ints and longs and doubles and so on. And that's why there are so many of these particular functional interfaces defined for you, because they're different types. The support that Java provides for primitive types is to avoid the overhead of so-called auto-boxing, which is what happens if you don't use these mechanisms, but instead wrap primitive types with references to work with the reference interfaces. So they have an awful lot of They have an awful lot of interfaces that come out of the box. So there's basically an explosion of functional interfaces that are defined in Java. Some people think that's a problem. Some people think it's a benefit. It really depends on how much time you're willing to devote to learning what's there. My sage advice to you is to take a look at the interfaces that already exist in the Java util function package and see if there's already one there that does what you want before you start trying to customize your own functional interface. It'll save you a lot of time and make your code more intuitive to people who are familiar with using Java. We're going to focus on the most common types of functional interfaces, things like predicates, functions, bifunctions, suppliers, and consumers. And you'll see that those get used a lot with other forms of Java functional programming, particularly Java streams and Java completable futures. All of the examples we're going to give when we talk about functional interfaces are stateless. And that's what you really want to strive for. If you can make your use of functional interfaces stateless, it makes it very simple to update your code to accelerate it by using parallel processing, most notably by using parallel streams. And if you play your cards right and you stick with stateless interfaces or stateless instances of interfaces, then switching from a sequential program to a parallel program is often just as simple as changing one method call from .stream to .parallel stream, although that gets us a bit ahead of ourselves here. So that's the end of the overview of Java functional interfaces.